Right, so we've got three talks today, and these are the folks that you will be listening from. The talks are from PG 18. Most of y'all who have not used Postgres before, you will have a tough time understanding some of the stuff, I would say. But no, we have asked our speakers to be starting the talks from the foundation level, right? We'll see how best we can accommodate within that 40 minutes. They'll have to cover their content, they'll have to cover the basics and make sure everybody's on same page. But how many of you have come from the PG Hyde website? How many of you have seen the PG Hyde website? So have you guys looked at the LinkedIn group, looked at some of the content that the colleagues have been producing, or you are, what's your expectation, right? Let's hear from a couple of folks here. What is your expectation of being here?
To learn databases.
To learn databases, okay. What's your expectation of being here? Here.
Networking and learning something new.
Learning something new and networking. We'll do both, I guess, for a lot of it. I mean, all of your college grads, or are you just passed out? College grads. Okay. Okay, cool. Without any further delay, I'll go ahead and grab Vikas to do the first round, maybe.
So let me introduce myself. I'm Vikas. I work in AWS and I'm a database consultant working mostly on different databases. And when I say databases, it is RDBMS, relational databases, right? So Postgres nowadays, you might have heard, right, is one of the very commonly used, very efficient, very new, not new, but recently it has got a lot of attention. Reason being, it's an open source and it is quite good in terms of sturdiness and ready to serve the enterprise, right? So most of the talk that you are going to see on these meetups is mostly from the enterprise perspective. We definitely will try to cover basics so that you can also enjoy those understanding what enterprises are looking for from a database and what enhancements are happening, right? So that you can get a understanding of higher side from your whatever you have learned in your semesters, right? So let me first define RDBMS means relational databases. Relational databases were a term that was coined by EF Code, like 60s or 70s, where he created 12 rules, and based on which he said if these 12 rules are followed, we can call it as a RDBMS or relational database, right? So Postgres is one of the important database. Now every year almost new version gets released, and because enterprises are using Postgres a lot, and almost all cloud providers are giving this Postgres as some solution, right? Be it AWS, Google, or Azure, right? And that's why every new version is coming up with very new enhancement that can cater to the earlier problems, solving the new problems and creating new, more efficient database usage. And in a simplified manner, what exactly RDBMS purpose is to keep your data persistent so that it doesn't get destroyed, and whenever it is required for any analysis or any activities through application or any other means, it is ready. And when I say ready, means it should be a slice of truth, means the whatever database contains, it should be correct, right? So that is the idea, ACID properties and all those stuff, right? So that is the understanding or basic understanding of RDBMS. And today's talk, I am going to cover more from the performance side, because when you want to extract data from any RDBMS, you want to be efficient, you want to be quick, means you don't want to wait for getting one row half an hour, right? So you want quick results. Now database not just only captures the data, there are multiple activities that happens, right? You insert the data, you create tables, you create foreign keys, indexes, and all those stuff, right? And these all things are created to make it efficient, right? And whole idea of keeping efficient is not only to keep adding things. It should cater to some meaningful way. It should be thin and lightweight in terms of usage as well, right? So I will cover a few topics. If you see on my screen, today's topic is deep dive into query optimization, vacuum strategies, and execution analysis. I give you a very brief one-liner. What exactly is query optimization? When you write select, insert, delete, update commands, and quite complex one. Database has to do a lot of activities. It has to parse the query, identify where these data are located, and based on that condition, it captures the data and sends to the client, right? But capturing this data requires a lot of algorithms behind the scene that is happening, which you might not be aware. Like when you run select star from a table, that's the thing only you provided the database, but behind the database is doing 100 things, right? It is utilizing CPU, memory, and other algorithms to get your data quickly. So query optimization becomes important because many times those complex queries become slow because of n number of reasons, and there are mechanisms provided by almost all RDBMS how to capture what exactly is happening behind the scene, so that you can tune your query, you can optimize your query if it is wrong or if it is not giving you the enough performant timelines in terms of execution, how to reduce that or how to measure that, right? Second is vacuum strategies. What exactly is vacuum? Because when insert, update, delete, etc. are happening, there are multiple things. Some pages are getting destroyed, some pages are getting newly created, new pointers are getting created, and these are kept in different tables or system tables, so that whenever somebody queries, it can quickly identify this is the right data, this is the old data or new data, and give you the correct data. So vacuum does is it identifies what is not required and keep it aside, so that your data queries or your queries do not get bothered because of these unusual activities or unrequired things, right? So that is called vacuum, like your vacuum cleaner in your home. What exactly it does? It removes the dust, it removes those unnecessary or unwanted things, right? So similarly is the task of vacuum, which is in Postgres. It removes those unwanted things. And then execution analysis. As I said, these queries which you write goes through a lot of activities, and that is called execution, right? And these execution you can tune or you can change or you can at least force in some manner. And there are mechanisms how can you force that and make it optimal. So this is one of the areas in practical or practicing RDBMS people will do is query optimization, other than installing and gathering the data or writing select queries. So it was also important part. That's why you might see in a lot of these talks or meetups, we discuss about these query optimization things and share those thoughts. If you have discovered during in your practical life or field experience, we share on those lines. Okay, so now the first thing is explain, analyze. So explain, analyze, what it does is, if you want to understand what exactly the query is doing, you run explain, analyze. Explain, analyze will execute that query and give you a more detailed execution plan, like how this query is executing different steps, and there are multiple options that is available to get more and more details. You can see those who are already worked in Postgres might be aware, from 13 to 18 I have covered. That these are the different options which were introduced at some point in time. The common one is analyze, verbose, cost, and all other things. Recently, if you see serialize, which was introduced in 17, and memory, that was also introduced in 17. Why this is required? Because earlier there were things there, the queries were not optimized enough, and we needed those data. So community developers created those enhancements, and these options are now available. Okay, so recently So my talk will be more from the perspective of performance, but looking at the point of view of new Postgres version, which is Postgres 18. So how Postgres 18 has enhanced and how it is affecting or might affect, or how you can utilize these new features in day-to-day purposes. So one thing is buffers. Buffers is nothing but the shared memory, because everything database is more IO based application, right? It also consumes CPU, but its more intention is towards doing IO activity, means data moving from one place to another place, right? So that's why buffer is the indicator of how you are using your memory, right? So earlier, before Postgres 18, if you wanted to see what exactly how memory is being used, you have to explicitly provide this input parameter called buffers, right? And then only it will give you details about this one, right? But in Postgres 18, that was made implicit, right? So it automatically included in explain analyze, so you don't have to provide buffer and you will get the data for buffers. So I show you one example. I just ran explain analyze, right? And you can see this is the explain plan for this particular query. This is a simple query. Select count from a employee, select count from a table. I have called it performance test table, and you can see these buffers details are automatically published. If you run this command without analyze in older version, you will not get that. Let me show you one example quickly so that you are comfortable over here. So I'm only going to use let me increase that. Is it better now? Okay, so this is the query. I'm going to run only with analyze, and if I run explain plan, so this is the explain plan which was generated, or explain plan command that I'm running, and you can see in 13 older version it is only showing you timings, right? But if I go to 18, I can automatically see buffer details, right? So all other versions, it's the same story. So this is good from a perspective of DBAs or developers who want to see these memory details by default. Okay, so this is one part. Now second part which was added is fractional row count estimates. Earlier row counts which was provided, if you look at the explain plans, is the font good enough or should I increase? Okay, increase. Fine. Okay. So earlier, these row counts which explain plan shows is mostly around integers, and means they added new enhancement to show more I would say decimal level. However, actual rows will be always integer, means it will give 2 rows or 3 rows. It will never go 2.5 rows, right? But the reason they added is to give an indication, because behind the scene in any RDBMS, whenever we are talking about RDBMS, we are talking about cost-based optimizers. You're not able to hear you? Slow. Say. Is it better now? Check now. Hello, hello. Check. Hello, hello. चल रहा है. Take this. Hello. Okay. So these decimal level row counts have been added because these cost-based optimizer uses these numerical values to identify how many rows are eligible, and this give an indication like there might be something wrong. That's why rounded figures are not coming. So it is just an enhancement more from a low level perspective, but just wanted to add, because if you see these decimal numbers, you can understand like either you are using Postgres 18, and probably there might be somewhere analyze command, or some histograms might not be having the full data correct data set, right? So that is one enhancement. Now another one which is important, which is called index searches. So what happened is earlier, if any explain plan you run, you will get details something like this one, right? But it was not indicative like how many searches, means index has been used, that was evident, but it is not evident like how many times this index has been used, right? However, in most of the scenario you will find that number of loops is same as the index searches, but there are corner cases where execution might differ, and in those cases this will be helpful to identify whether the index has been actually searched or it is just being used in the explain plan, because that might have increased the cost of optimizer or cost of that query, but might not have used. So that is an indicator in terms of understanding whether the query you have written and the index that you have created are optimal for that usage or not. Okay. Fourth point is memory and disk usage for nodes. So certain queries like materialized views, windows aggregations, and common table expression, or CTs what we call, which starts with, those are actually little complex in terms of how execution happens. For example, CT or common table expression, it creates temporary tables behind the scene, or temporary space or storage is consumed. But sometimes if it is efficient enough, it will consume the memory, or it will create it in memory. But those details were not available through explain plan. So recently that has been added, so that once you create materialized views or windows aggregation or CTs, you will get more details like how much memory or how memory is getting utilized in these queries. So I give you one example. Let's say this is a table which has 600,000 rows, and if you run explain plan for this query, if you see these two lines represent Windows query. This is called Windows function, where you provide partition by and order by. So what is happening? This is identifying the average price across categories, means within the category. So that is why, because it's a subset of that whole data which is extracted by this particular query. If you look, this is just a from clause, no where clause. So that means it is going through all the rows of this table. But this particular window is saying only for categories I need average price. So this is small window. So that's why it is called Windows function. Now in this Windows function, let me first share. So this is the Windows function explain plan. And if you see, these are the few new things added on Postgres 18, which is identifying which window it is using, or which window function is indicated by, or used in the explain plan, and for that window how much memory storage has been used. This was not earlier available. If you look at the version 15 explain plan, you will not see. It will only show like there is a window aggregation happening. This will also show like what query this explain plan represent, but it is not showing how much memory. So that will help in terms of very complex queries. Many a times you are struggling to identify what exactly is the consumer out of how many. Let's say these are two windows, but in many complex queries you might see multiple windows functions have been written, especially in reporting queries. So it becomes very tough to identify which window function is non-efficient and how to mitigate that. And that's why this explain plan helps in that case, in those scenarios. And just a small a summary over here, you might see a lot of sorting happening. For example, if you look over here, there is a sorting happening. This sorting is happening because there is an order by on the product price, right? And any sorting, if you recall from DSA perspective, right, it requires some temp space, or there is some extra space that is required so that it can sort the data as required, right? And this sorting happens if it is very small, probably it can be completed within the memory. If it is more, then it will do some heap sorting, or it will create different various heaps, and then if it is beyond that, it will actually create files on the disk, and that is the slowest one. And here if you see, because as I said, like 600,000 rows are there, and I'm using a very small Postgres version, and that's why it is spilling over to disk. So that also helps DBAs to identify, okay, this sorting is taking a lot of time, because disk sorting is happening, means data is getting written to disk, and then sorting is happening over there, and disk is always slow part, right, in any computer science applications. So these are the additional things that were added in Postgres 18. Now coming to another one, wall buffer. Wall buffer is write ahead logs, which is used whenever insert, update, deletes, or write activities are happening. What is the purpose of write ahead logs is, in a very layman sense, is whenever you are deleting, updating a row. Update is a good example, because if you break down update, it is exactly insert and then a delete, means you are inserting a new row or updating that row, and then you're deleting the old one or the old data, right? So in that case, these temporary activities is logged into a file or a location called wall, right? And that is why it is important to understand how many times, how much buffer usage or wall activities are happening, so that you can understand whether it is an efficient write activity or not. So there is an important element added to explain plan called buffers full. So if you look at this explain plan, where I'm inserting 500,000 rows in a table in one go, so what exactly is happening is, this is a lot of data, and if you look at the wall records, it is showing buffers full as 11,000. What exactly buffers full means? There is a small space, let's say 2 KB of wall space you have given. So 11,000 times that wall space got full. Reason being, because it's a massive data that you are inserting in large. So that is an indicator. Probably if you are observing lot of these buffer full, that means it's a right time to increase that pool, so that more these full buffer full actions gets reduced. It will not get eliminated, but it can get reduced, because think of a scenario where hundreds and thousands of queries are running on a server, right? So this because when it is full, you cannot pour more into it, you have to wait, so that increases the wait time. So that's why it is important element to look into when these wall activities or inserts are happening, and that is why this was added, to give more details to database developer. So this is another important enhancement that has been done into the Postgres optimizer, called disabled node indications. What exactly is disabled node indication is, let's say there are multiple runtime parameters. For example, one is enable sequential scan. What it does is, when sequential scan is on, that means sequentially it will read all the pages of a table, right? And it will give the result. There are scenarios in which there is no other optimal way but to go through each and every page of the table. But let's say this, and this is always a costly affair, and this is what we are always looking for whenever we are doing performance tuning, that is the query plan showing any kind of sequential scan. If it is a sequential scan, the probability is high it will be slow, and the next step is to identify, can we reduce that, or can we remove that, or can we eliminate altogether this sequential scan. So that's why many times you might see sequential scan has been set off either at server level or at the query level. You can do at a query level or session level as well. So here the example that I'm showing is session level. I set this enables sequential scan off and running this query. If you run this query, I'm giving a where clause which is like category on book. So in this behind the scene, this book contains almost all the rows contains this data which starts with book. So that's why it performs a sequential scan. But since it is off, there is no mechanism to identify whether it has been chosen by a database or whether it has been off. So they have introduced this section called disable true. So that means this runtime parameter has been disabled, but because there is no other option for optimizer to give the result for this query, so that is why this plan has been chosen to run the sequential scan. You can see this sequential scan. This is parallel because multiple threads are doing these activities or this sequential scan, because this is another optimizer thing in Postgres where multi-threaded or multiple threads can do the sequential scan, so reduce the time. Otherwise, if it would be one single thread, probably you can understand there are two workers doing the activity and taking 116 millisecond. If it would have been one, then probably you can linearly think of 200 milliseconds. So this is a good indicator, like is this or these kind of runtime parameters have been switched off. So that gives an indicator like can we switch on or change that. So it's an indicator which helps DBAs in identifying these situations. Another important thing which I personally have seen many times, because if queries are running slow and you ask developer, can you share the explain plan, they will share the explain plan. So I asked to keep the explain plan using these settings. What is the purpose of this setting is, this setting shows what was the runtime setting that has been chosen or that has been set during that session. So sometimes you might be trying multiple options to make that query performant, and you are changing sequential scan off, nested loop off, and all those kind of stuff. But if these settings are not not provided in the explain plan, it will not show whether what was the settings chosen for that particular session. Since I have used and I have set this parameter off in this session, so it shows over here that this sequential scan is off. So that also helps in during production issues, like to identify, okay, this particular parameter was changed while executing that query. So it helps us identify, can we get that removed or not use this particular parameter and give me the results. If you do not use setting, you will not get this this row. So you will not be able to identify whether some setting has been changed during execution plan extraction. Okay, so look at the version 15 plan. It is not showing anything. Settings is shown just because I have used that explain plan settings. Otherwise, disable true is not there. So that is an extra enhancement, more from the I would say advanced level usage of explain plan. So I summarize over here. There are multiple dimensions in explain plan, but what I have shown is the new enhancement that has been introduced in 18. So in 4 bullet points, what I can say is how to identify the bottlenecks in any non-performant queries. Look for high buffer reads, that means high memory is getting utilized. Check for fractional rows. There is a high probability some histograms or some statistics of columns or table might not be in place or not correctly extracted. Then there is a memory spills to disk. That means there is a chance either you increase the memory or look into from that perspective whether it requires any indexes or there can be some tuning on the query level. And then wall buffer pressure, because it will help you identify how much write activities are happening and is it slowing down just because you have not provided the enough memory to it. Okay, so here I am ending up the explain plan part. Now I will move to vacuum and freeze optimization strategies that have been introduced in Postgres 18. So as I said, vacuum is very important part of Postgres. You cannot remove or see Postgres and vacuum separately. It is inbuilt, and we always suggest to keep auto vacuum on, because auto vacuum or vacuum activities are important from perspective of how transaction IDs. I know these are little advanced topics, but these are the basic pillars on which Postgres works. and these vacuum activities are very important. If it is not running optimally, it will slow down your Postgres. It will create nightmares for you when you are running for enterprise. Even normal usage also you can face issues. So a new parameter has been added, and every release there is one thing or the other added definitely for the vacuum related stuff. So this time they have added what they have called this parameter is max eager freeze failure rate. So that helps identify when this parameter is enabled. The default value is 3%, means 3% of the full relation pages. Let's say a table has 100 pages, then probably 3% or 3 pages it will take up for activating or running this eager freezing. Okay, so what are the challenges? If vacuums are running, right, but it is all visible pages and there are no dead tuples in it, auto vacuum skips that pages. But there are scenarios in which there are no dead tuples, all rows are visible. When we say visible, means it is ready for usage or ready for means. Okay, let me take this way. Visible in Postgres means, let's say a page contains 10 rows. So that means 10 rows are visible for you, and 10 rows you can use it, right? There are no dead tuples in it. But if there is any transaction happening on the 10th row, then the visible will be 9. The 10th row will be in the transaction, right? So that transaction is something we have to wait unless it is committed, and then we will froze and make it visible once this part is committed. Right. So this eager freeze failure rate helps in identifying those where all rows are active but still freeze activity has not happened. So it will aggressively check for can I apply this freezing? If yes, then it will apply and make those rows available. Otherwise, what will happen is every time auto vacuum will run, it will identify those pages unnecessarily, even though there is no dead tuples, and waste the time. So that's why we want to reduce the effort of vacuum to the right places where actually its activities are required, right? And here are the example. How can you set at the table level or the system level? By default it is 3% at system level, but you can change at the table level. Okay, now getting to truncate control. This is a new feature added. What it does is, if any pages which doesn't have any rows in it at the tail or end of the relation or a table, it can eliminate that even during the vacuum. Earlier it was not during the vacuum we don't use to do that. So this feature helps in identifying earlier those tables or those pages which can be eliminated, right? So that helps in reducing the overall. Means, let's say you have thousands of tables in which almost all tables are aggressively used. Then there is a lot of those tables which can be eliminated, but it cannot be done because these features were not available. Now it can be done. Okay, some more enhancement has been done on the vacuum side. Earlier, how much time that vacuum has taken was not covered into the system table. It used to cover how many times the vacuum has run and what was the last time it has run, but how much time it has taken, it was not covered. Because let's say a vacuum is running for let's say half an hour. We didn't have the mechanism in tables or system tables to identify that. We had to look into the logs or other tables to identify this vacuum is running. So now this is captured as a system table. So easily you can select on this particular table and see which vacuums or which activities has taken more time. Here are some of the strategies which now may be used after the Postgres setting to set up aggressive. For example, in aggressive mode, we generally used to only change these parameters, but now we can also enhance or use this parameter to make it aggressive. Means aggressive means running vacuums more frequently on the tables. I will skip these two things because it is more on alerting and monitoring side, which I have already explained. This is another example, which is skip scanning. So earlier, what used to happen, or almost all RDBMS, if you are creating any B tree index, let's say I'm taking an example of this particular table. I have created an index on these 4 columns. So unless until you provide this particular region in your where clause, this index will not be used. That was the challenge. So in case you provide category, sale date, anything, it will always go for a sequential scan or any other scanning, but it will skip this index. Reason being, this is called the leading node of the index. If it is not provided, then there was no mechanism to identify. From Postgres 18, they have enhanced the optimizer. In that case, even leading values are not provided, leading column is not provided. It can take help of that index using other columns to identify or use that index. So let me quickly show one example. Skip scan. Here is the query. So I'm providing a product category, which is second column, and date. And if I run, you might see 13, it is using sequential scan, 14 same, 15 same, 16 same, 17 same. On an 18, you see index is being picked up. And index condition is using the second column, right? It has used index search 9 times, but the cost has decreased because it has utilized index rather than doing a sequential scan across. If you look at other, it is doing a sequential scan, means it is going through all the pages and look at how many rows it has to remove, right? So this is called skip scanning in Postgres 18. Now let me go to, these are some samples, I will skip that. Okay, now this is an important one which has been added. This is called self-join elimination. So in case you are using self-join, so for example, look at this query. This is the same performance test. It has a primary key on ID column. What exactly is happening? We are joining these 2 tables on the same primary key, right? And providing a department or where clause. If you look, I remove this one, this has no reason to make any sense over here, because it's already a primary key, right? And we have given the other search argument, which is a department. But there was no mechanism to skip or eliminate this extra join condition in the earlier versions. So that's why this in earlier version it used to run scanning of both the tables. So if you look at the plan, so so these are the 2 scanning happening on the same one, but this condition is met in Postgres 18. Okay, let me show through an example, it will be much better. Same query, right? If I run, so in 13, if you see, it's going through this condition and looking at both the tables, E2 as well as E1. But as soon as I move to 18, it only scans one table using this index, this E2. Because it has eliminated, because it identified it is the same join on the same primary key, and primary key is same for each row, so there is no meaning to use the second table and skip that scan or the activity. Another one is OR clause. Earlier OR clause used to be a problem because when OR clause is provided, the same index get used thrice or multiple times, but in Postgres 18, what they have optimized is it will use as an array and it will utilize those index only once. So let me show again with an example. OR clause, see ITHR legal, these are all parameters that I have provided, and if you look at the 13, it is doing sequential scan using these 3, same as 14, but as soon as you move to 18, it only uses this index once using this array. So this reduces the complexity of using multiple times the same indexes, right? And eliminates the costly optimizer activity. I will skip this one because this is more a functional dependency group by, in which what is happening is, in case you do not provide these two columns in a group by, it used to throw an error that your select column is missing this one. But in case optimizer has identified that ID column is unique, even if you do not provide department, it will not throw error. So this is I would not say enhancement only, but a different way where if group wise are you're grouping on only one column, it will not throw error. Okay, I will take one example to show a query which is slow running query, and identify how this query which is running slow, what exactly this query does is, it identifies those departments or the number of employees who have salaries less than 80% of the whole department. So this is simple query, but it is not efficient query. And if you do let me try to exemplify it. Yeah, so here is the query. If I run it, it takes time. It only has few thousand, 5,000 rows in the table, but it takes lot of time. And if I run the buffer activities, if you look at this one, 13, 14 or 18, it always takes lot of resources, and that is why it is slow. Reason being slow is there is this is called a sub plan, which is executed at runtime and executed for each row, and that is why it creates a lot of buffer usage. And once we calculate the buffer usage, it comes to around 3 GB. This table itself is 1 MB table, but it is using buffer pool of 3 GB. Reason being the way it is executing behind the scene. By a simple mechanism of optimizing that using with clause, let me see if I have written over here. Yeah, so I did a very simple thing, which is CT or common table expression. I extracted as a separate part this 80% salary across the department and used the same query, just providing a join over there, and it started to taking only 3 MB of buffer space. So the reason I put it this example is to show like how simple queries using only having 5,000 rows, not very complex activities, can eat up your memory spaces. And that's why it is important, the enhancement that is happening in each and every version, and different parameters are being tuned so that these inefficient queries, which looks very common, intuitive, you can tune it, and there are various mechanisms to tune that. And how you identify those issues? Through explain plan, right? So if you look at the explain plan, it shows there is a sub plan, and this sub plan is used for identifying the salary is greater than or less than, and this sub plan unfortunately runs for each and every row. So as soon as you increase, I have seen this query, if I increase this row this table by just 30,000 rows, it takes 10 minutes to complete that. And the same with using query with clause or CT, it takes almost constant time. So I will end up over here capturing most of the thing in the Postgres setting from the performance point of view. And if you have any questions, let me know after this meetup. Thanks everyone for listening me. Yes.
Sir, I have a question.
Sure.
We 80% students are here, and we are using MySQL.
Very nice.
So
Very nice.
so how I the shift this and what is the
You want to move to Postgres?
yeah.
Yes, you can move to.
What is the benefits for the how it differ?
See, it is one. MySQL is another optimizer, very similar to Postgres. It has its own mechanism of working. So, what is your purpose of shifting? You want to learn, or you want to see how it works? So, most of the underlying mechanism of RDBMS is same, right? Postgres provides its own way. MySQL provides in its own way, right? So you can create table. You can explore that. But I'm not able to understand what exactly are you trying to ask.
Actually, I want to use this.
Uh-huh.
So, what is different in MySQL and this is
So recently, what we have identified is in Postgres, a community is doing much more frequently updates, enhancing needs, and because many cloud providers are also using that, so you see a lot of things are happening in this space. It is frequently making changes, identifying the gaps, putting into the new data. Right. So it started 2020 it was version 10. Now we are in 2026. It is version 18, and every version there are new enhancements happening. So definitely it is growing much faster than the MySQL space. And I have seen personally that if you increase the number of rows or the quantity of rows in MySQL, it doesn't stay as better as